All right, consistency, guys. All right, so I really needed to talk about atomicity and isolation first to talk about consistency, right? Although consistency is the second property or an asset, right? And the reason is atomicity and isolation leads to consistency, in my opinion, right? And the way I see it, there are two types of consistency. The way I see it here, and the first one is consistency in your data, and the second one is consistency in reading the data. And let's talk about each one of them, and and let's talk about which one of those the NoSQL guys came and tried to improve upon. Okay, and try to kind of relaxed here. Consistency in data. Consistency in data is essentially is defined by the user. It's something that the user defines in their table schema that says, hey, that this view and this view should be consistent. Like say the sum of the money in this table should equal the sum of all the balances, or the number of likes in this picture should equal the number of the users who actually like that picture. So this is a consistent view that the user defines. Okay, usually it's enforced by referential integrity like foreign keys and primary keys, so you ensure consistency in your data. And it's also ensured by atomicity and isolation. We saw that. We remember when we got the blue screen of death in the middle, right? We just lost my data, right? Just went away, and I got an inconsistent balance sheet as a result. We got 900 and 500, where 100 just went away in the thin air. Okay, so the lack of atomicity leads to inconsistency in your data. Okay, isolation. Do I need to say anything? We saw all that stuff with isolation, right? Giving all this false reports as a result of lack of isolation, right? The moment people are changing my product sales while I'm reading this data, I'm gonna get bad results. I'm gonna get an inconsistent result. Okay, although my product says the sum is 130, I can see it, I can sum it, but the actual total is saying 155. That's bad. Okay, so lack of isolation leads to inconsistency. It's up to you as a user if you can handle, if you're okay with that inconsistency or not. Sometimes it leads to corruption inconsistency. If you're not happy with that, like a bank transaction, you cannot probably be happy with that. Product sales, probably not. That's bad, right? Pictures and likes, we're gonna show that example. See, like this is an example, right, where consistency in my data is really not a big deal, right? Like we have two pictures here. This is a blob of the picture. Let's say this is an Instagram implementation. We have a blob of the picture, and we have the number of likes, right? Hussein might say, Hussein, why are you adding a field called likes? What is that? Okay, why don't you just query this table and just get the number of likes? Performance is the best short answer for this, right? So you would add a likes field here, which will contain the total number of likes in this picture that this picture got. And there's another table called picture like, which includes like, hey, John liked picture number one, Edmond liked picture number one, John liked picture number two. So if you sum this, right, picture number one got 2 likes from John and Edmond. That's correct. And then picture two got 1 like. It's one from John. So that's a consistent view. But if you saw, like for example, this is 4 and this view doesn't represent it, that's an inconsistent view. It's up to you if you're happy with that inconsistency or not. And that's a very critical question, because based on that, you can adjust the performance, you can adjust the consistency, you can adjust scalability, you can adjust isolation, right? Based on what can you give up as an engineer. As a software engineer, you really guys need to think about every single aspect of that. What can you give up? That's why you have to understand the requirements and then ask yourself, what can you give up? You're telling me that Instagram, if Kylie Jenner gets like 5 million likes on a picture, 5,032 likes, if I clicked on that and view the 5 million, are you telling me that you're gonna match? I betting everything you want that they are not matching. this is impossible to get a consistent view on this, right? And they don't care because nobody's gonna fiddle through 5 million users anyway, so they can give you an approximate number, and they can be off. Those two views can be off by even 100,000. YouTube is the same, subscribers, right? Why do you think YouTube is showing you like my subscriber is 6K or 6.2K? Because they cannot guarantee you that I have exactly 6,032 subscribers, okay, or 23, or even PewDiePie, right? He has like what now, almost 95 million subscribers. That number is not exactly accurate to the actual number of subscribers that he actually got. It's an approximation because they decided it's not important to maintain the consistency of this thing. Because why? First, because nobody's going through 99 million subscribers, so they are preferring performance over this consistency. Sorry about guys, sorry about that, going to a tangent, but I think it's critical to this. Let's talk about the other concept of this. Consistency in data, sometimes it matters, sometimes it doesn't. Consistency in reads, same thing. Sometimes it doesn't, sometimes it matters. So we'll think about that. Now, consistency in reads is very interesting. And what it means is like, if I update something, if a transaction updates something to the database, let's say I update a value X, and that X gets persistent, and then another transaction start reading that, it better get the value X. Hussein, what are you saying? That's obviously ta freaking da, right? Obviously, it has to get the same value, but not necessarily. We're going to talk about the concept of eventual consistency here. So that's inconsistent read. If I committed something, can new transactions see it immediately? Okay. And here's the thing. This type of consistency is unavailable on both relational and NoSQL databases. It's a big statement here. Okay. Both databases suffers from this consistency. Okay. Including Oracle, including Postgres, including MySQL. Those databases are not consistent in reads. And let me explain here. When you have one server and you're committed something to it and you read from that one server, life is good, right? Life is perfect because you have one freaking server. But the moment you start adding other servers, let's click about this is Postgres or MySQL, right? What you're gonna do essentially is you're gonna have one server and you create a replica of that server, and that is like even one-way replica or two-way replica, and just gonna start pumping data to the replica, right? And now obviously you need to add multiple replicas for horizontal scalability, right? You cannot serve 7 million people off one database, right? YouTube started doing that with one database, and they scaled it up to multiple, and they implemented now Vitess, which is this new fancy stuff on top of MySQL that gives you like sharding, on the fly sharding and all that stuff. We're going to talk about that in another video. But essentially, the moment you break things up into these replicas, into this essentially the other databases, right? These secondary databases, called follower, leader of follower nodes, right? The moment you start doing that, you are inconsistent, sir. You will become inconsistent because you write to the primary node and someone else reads from the secondary node. The secondary node takes time to get the value propagated. There is networking going on. There is delays, latency until the secondary node gets the new value. So you're gonna get an old value, my friend. You're gonna get an old value, right? And that is inconsistency. So this problem, and a lot of people get this wrong, inconsistency. So the relational database is inconsistent in reads, right? The moment you start breaking them into horizontal scalability, multiple servers, you're gonna get inconsistency, right? So they are consistent when there is one big nice server, right? The moment you break them up, they are inconsistent reads. You're gonna read it, but someone will gonna read an old value. And it's up to you now as an engineer. Are you happy with this old value? If you get a slightly older subscriber count, okay, that's completely fine. If your video, the latest view, and that's what like YouTube does, right? There are many servers and all these rights going to multiple databases, and then they eventually sync back into one big server, one big database, right? And then if I'm reading that view versus someone from Germany versus someone from Japan reading that same video, we're gonna get different results because we're reading different replicas. We're reading from different follower nodes, and that's okay, right? Sometimes that's okay, sometimes it's not. So now there are a bunch of people who say, you know what, we don't want to enforce that thing. Is this all this stuff you guys are doing silly? This ACID thing is silly. And the fact that scaling relational databases has been always hard, right? Because was designed in the 70s to be a one big beefy machine, right? One big beefy server, the database is there, and that's it, right? In this era, those guys said, okay, you know what? I'm gonna give up consistency because you guys already don't have consistency, right? I'm gonna relax a little bit of these 4 properties, and I'm gonna give you a better scalability and performance, right? So I'm gonna scale horizontally. I'm gonna add a bunch of other servers on the sides, and then just we're gonna start sharding, doing all these things in a distributed manner. Okay, so that's essentially what they did, and thus the NoSQL databases came into picture. Okay, so they give up consistency or on favor of scalability, which the relational databases are really, really hard to do, right? Relational databases where you have to implement a follower node and leader node, and they start replicating, pumping changes, right? And the NoSQL one gives you a scalability. You can add just nodes and it will scale nicely. But if you're looking for isolation and all that fancy stuff, you're not gonna get it, obviously, right? Okay, you're not gonna get all these properties off of this. You will get this new concept called eventual consistency, which is, to me, is just a marketing term. Okay, eventually everything is eventually consistent. Duh. Okay, so it's like if you read the value, you get an old value. If you wait a little bit, you're gonna get the latest value essentially, right? So to me, eventual consistency, both the relational databases and non-relational databases suffer from this. Okay, eventual consistency.